So Chapter 7 is concerned with chemical bonding and molecular geometry and begins with a brief description of the ionic bonding model. So we've divided the periodic table into two types of elements, metals and non-metals. And this gives rise to three possible types of bonding. We can have metals bonding with non-metals, non-metals bonding with non-metals, and metals bonding with metals. When metals bond with non-metals, we get what's called ionic bonding, and we will see that this is the result of electron transfer. When non-metals bond with non-metals, we get what is described as covalent or molecular bonding, and we will see that this is a result of those atoms sharing their electrons. Later on, we'll be talking about the structure of metals in the chapter concerned with solids and liquids, and we'll be talking about how metals bond with other metals. This is called metallic bonding, and that's a result of what is often referred to as electron pooling. So focusing in on ionic bonding, the type of bonding that forms between metals and non-metals, the reason that these bonds form is the attraction between oppositely charged ions. So we will have one cation forming a bond with one anion. And the strength of this ionic bond is described by something that is known as Coulomb's law. And Coulomb's law states that the energy of the attraction between two oppositely charged ions is proportional to the product of the charges of the ions. And typically we're going to say the charge of something, we're going to represent that by the symbol Q, and then that's going to be divided by the distance between the two ions, which can be understood to mean the radius of our cation plus the radius of our anion. So what does this tell us? It tells us as the charges increase, our bond gets stronger. So bond strength increases. But it also tells us that as our ions get smaller, our bond strength is bigger. Okay. So ionic compounds, and we'll see this in the chapter on solids and liquids, they form what we call crystalline solids. And crystalline solids occur when ions organize themselves to maximize attractions between oppositely charged ions and minimize repulsions between like-charged ions. And a classic example of this is the structure of sodium chloride. And in this structure, the smaller spheres here are the sodium ions, and the larger spheres are the chloride ions. And you can see that the ones with the same charge are always diagonal from one another, whereas the ones with opposite charges are always along the edge of the square between those ions. And you probably know that the edge length of a square is shorter than the diagonal of a square. So the ones with opposite charges are always closer than the ones with the same charge, and as a result we maximize attractions and minimize repulsion. Okay, so that concludes this really short section. If you have any difficulty with the content, please just reach out to me and I'd be glad to help.